Have you ever wondered why an object in motion tends to stay in motion and an object at rest tends to stay at rest? This fascinating phenomenon is not random happenstance, but a fundamental principle of our universe, governed by the laws of motion. These laws, first articulated by Sir Isaac Newton, elegantly explain the ballet of the cosmos and the dance of everyday objects around us. So, do you feel that curiosity stirring? Good, strap in as we're about to delve deeper into the fascinating world of motion. The first law of motion, often called the law of inertia, is all about resistance to change in motion. Picture this: you've absent-mindedly left your coffee cup on the roof of your car. As you drive off, the cup slides off the roof. Why? Because while the car moved forward, the cup wanted to stay where it was. That's inertia in action. Or consider another common scenario. You're in a vehicle that comes to a sudden stop. Your body lurches forward. Again, this is inertia. Your body wanted to keep moving even when the vehicle didn't, but here's the key. Both these examples involve an external force. In the case of the coffee cup, it's the force of the car moving. With the passenger, it's the force of the vehicle stopping. So, without an external force, an object will not change its motion. That's the first law of motion for you. Now, what happens when a force does act on an object? That's where the second law of motion comes in. This law states, quite simply, that force equals mass times acceleration. Let's break this down. Imagine you're pushing a shopping trolley. It's easy to get it moving, right? But what if someone dumped a load of bricks into that trolley? Suddenly it's a lot harder to push. That's because the mass, the amount of matter in the trolley, has increased. Now consider acceleration. This is how quickly an object changes its speed. If you push the trolley gently, it slowly begins to move, but if you give it a big shove, it zooms off quickly. That's acceleration. So when we say force equals mass times acceleration, we're saying that the force you apply to an object is equal to the object's mass times how quickly its speed changes. In essence, the more force you apply, the more acceleration you get, and the heavier the object, the less acceleration. Finally, let's talk about the third law of motion, which you might know as every action has an equal and opposite reaction. This law is all about the symmetry and balance in nature. It's the reason why we don't float off into space when we jump, and it's what allows rockets to launch into the stars. Imagine you're on a boat and you decide to jump off the edge. As you push off the boat, it moves in the opposite direction. That's the third law in action. Your force pushing off the boat causes an equal force to push the boat away. Similarly, consider a rocket launching into space. The rocket's engines expel gas at high speed in one direction, and in response, the rocket is propelled in the opposite direction. So you see, this law is all around us, governing the way we interact with our world every day. So for every force, there's a force of equal magnitude, but in the opposite direction. That's the third law of motion. As we journey through the laws of motion, we discover that these fundamental principles govern everything around us. They are the invisible hands that shape the dance of the cosmos, from the spinning of galaxies to the fall of an apple from a tree. Let's take a quick trip back through these laws. First, we have the law of inertia, the first law of motion, stating that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This law explains why we don't suddenly float off the earth or why a car doesn't immediately stop when the brakes are applied. Next, we have the second law of motion, which tells us that force equals mass times acceleration. This means the force applied on an object is directly proportional to the rate of change in its momentum. So, a heavier object requires more force to change its motion than a lighter one. Lastly, we have the third law of motion, the law of action-reaction. This law states that for every action there is an equal and opposite reaction. This is why when we jump off a boat, the boat moves backwards. And there you have it, the laws of motion, the very principles that keep our universe in motion. Remember, every object in our universe is governed by these laws, from the smallest atom to the largest galaxy.